So it looks like we have a few people joining. Okay. Do we have Diana yet? I don't think we do. So we've got transcription going on as well. If that distracts anyone, let me know. But I think it's good so that people understand what's being said properly. So let me know if it becomes a distraction. Okay, I'm going to start. I'm not sure where Diana is, but she's going to join us later. So this is a WIT event, and the idea is that we have conversations in the cloud. We're going to try and get everyone in North Highland to know a lot of stuff about the cloud. My specialty is in AWS and Amazon Web Services. Diana is more a specialist in Azure. I have done a bit of Azure, but I'm not an expert in that. We're both master practitioners in the technology capability in the delivery section. And so we both wanted to share some information that we've learned about the cloud over our careers, and also to have, it's more of a two-way conversation. So if anyone has any questions as they go along, please ask. And we've got some slides here to sort of prompt us, but it's not really it's going to be quite a fluid thing. You can ask questions around it as we go and so on. There are some resources I've linked to here that we've written about cloud issues within North Highland and AWS issues in the ebook there. One of the articles there is a glossary, and one of the articles is like a cheat sheet, which helps you understand AWS and Azure. For those that are interested in Google, I'm not an expert in Google, but I found the Google Ground School, which is all about cloud computing in Google. And there's a link there. And I'll send out these slides at the end of this, and everyone can use that. This is being recorded, so you can always come back if you need to. So just the first point is that we want to get as many people as we can within North Highland certified, preferably at the moment in AWS, but also in Azure and Google Cloud as well. The reason AWS is so important right now is we have a big project coming just after Christmas where we're going to need a lot of AWS skills. So if anyone doesn't know about AWS certification, there's a lot of levels that you can get of certification. Cloud practitioner is really kind of simple. You should be able to get that no problem after a couple of these sessions. The associate level it's a more deeper level exam, and you have things that are kind of broader as well, so a broader set, but it's not as deep as the professional level. The professional level is broad and deep in a lot of areas. And then there's the specialty area where there's 3 different exams. There's the security, the big data, and the advanced networking. So if anybody's interested in doing those, you go to aws.training, and there's a certification panel in there that will help you sign up for certification. There's also a learning library in there with lots of resources. Also, North Highland has a lot of AWS and Azure, and I think Google as well, training courses. If anyone needs help finding any of that, just contact me and I can help you, or you can just search in the Learning Lab. Certifications, exams, and practice exams are available on that AWS training site that I just mentioned. You can take exams, you can get your certifications, you can share your transcripts, you can do practice exams, which are very useful. I think normally they're between $20 and $50 per practice exam, but they're really good to find out if you're going to pass when you take the real thing. So it's a really good way of doing that. And this is an example of that here, taking a practice exam and so on. This is the learning library on AWS training, and there's lots of videos on there and lots of step-by-step guides. It really is very useful. Azure has a very similar set of training and certification options as AWS has. They're just obviously at a different URL, but they're very similar, very detailed. If you can use a search engine, you can find a lot of training. YouTube is really, really good. YouTube has a lot of videos. I'm really boring. I sit on a Saturday morning in bed watching YouTube videos about cloud technologies. That's how sad I am. AWS and Azure and Google and so on. and there's all other kind of things as well, of course, in YouTube that you can learn. So there's some links here. Again, you'll get these slides. These links will be really useful if you want to learn more after this. I want to point out a couple. The tutorialsdojo.com has a lot of AWS cheat sheets that are free. They are very good. And the Amazon white papers, they're very good for learning a lot of the stuff you need for some of the exams, some of the certifications. But there's a lot of resources here. And if you need more, just come to me and I can help you with that. These are my chosen, if you're going to do AWS Solution Architect Associate certification, these are my chosen training courses that are really good for that. I have a course myself as well, which I am going to do internally within North Highland as part of these cloud chats kind of thing. But there are also two out there online that I would suggest you consider. The Cloud Guru one it's expensive to join, but it's very, very good. The iCollege one is very cheap, but it's actually pretty good as well. So, consider those. If you're doing the professional level, which is more in depth and in breadth level, these are some options. And again, I've got a training course as well that can help you through some of that too. Again, you'll get these slides with these links. So let's talk about cloud models and cloud paradigms. So you might have heard of infrastructure as a service, IaaS. Infrastructure as a service really means rather than setting up a server in your office or in your server room, you basically just go point and click on Amazon or AWS.com or in Azure or in Google Cloud, and you just basically create a server just on demand, just when you want to, just click ops. And it's really just answering a few questions and it will create a server for you. And then you can do things like create things like firewalls, you can create things like load balancers, anything you need to create the infrastructure of your system. You can do that ClickOps style. There's also other options, and we'll talk about that later. But basically, most people use the infrastructure as a service option as the first step into the cloud, typically for a lift and shift paradigm. So lift and shift means I have this server on my desk at work or in my server room or wherever in my data center, and I want that exact server to appear in the cloud. So what I'm going to do is I'm basically going to just move that server into the cloud as is without changing too much. And infrastructure as a service allows you to do that pretty easily. So that's pretty good for that. You don't have to plan ahead pretty much. You can just point and click and create. So it's great if you want to just test something in the cloud, or if you want to just do a proof of concept in the cloud as well. It's good for that. Pretty much AWS handles all the hardware and basic setup for that cloud version of your server. You have full control of the operating system, though. You can add patches, you can change a lot of stuff in there. You can you can change the firewalls and build the firewalls so that there's security in there too, and so on. But the big benefit of it is that you don't have to have a team of people managing and looking after your hardware in the cloud. A lot of the hardware stuff is handled for you by AWS. And we'll go into more detail about what AWS does. And this is the same whether you're talking about AWS or Azure or Google Cloud. In AWS, infrastructure as a service typically is about the servers, and you're talking about something called EC2, which is Elastic Compute Squared. In Azure, they just call them virtual machines, which is basically what they are. And I think in Google, they call them something similar too. So that's infrastructure as a service. Platform as a service, or PaaS, that refers to you not having to even bother with setting up a server in the cloud. You literally just write some code and you kind of throw it at the cloud and the cloud runs it. So it makes it even easier. You don't have to do all that management. Now, a lot of clients, a lot of customers are going to be scared to make that step and they want to do the IaaS first, that first step first, because this is a bit scary for them. But once you really understand the cloud, platform as a service is great, because if you're a programmer, you can just write some code, upload it pretty much as a file, and it will just run in the cloud. And there's different ways that you can do that, but we can talk about that later. Now, note that this phrase is misused. Some people use platform as a service to mean something else, and I'll talk about that in a second, what that is. So really, platform as a service is anywhere where you do not need to configure or set up any infrastructure or any operating systems or any databases, and it's just there. And this is what we call the optimize for cloud paradigm. So you're actually optimizing your system and running it in the cloud, so that you don't have to do all that configuration and so on. So some examples of platform as a service are what's called Azure Functions, AWS Lambda or Fargate, EKS to some extent in AWS, and AKS in Azure to a slightly different extent. Now, EKS is Elastic Kubernetes Service, and AKS is Azure Kubernetes Service. Now, they to some extent are a platform as a service. They're getting more towards that. EKS more than AKS. And basically, you just throw a container at Kubernetes and it runs in the cloud pretty much. There is a little bit more configuration you have to do with those, and sometimes you can see more of the infrastructure in those, but pretty much it's platform as a service. So you simply write the software and it runs in the cloud. Software as a service. Now, this is the one that everyone gets confused with. Some people call this platform as a service and they get that confused. So there's two types of software as a service. There's the consumer side and the host side. So for example, everybody here uses the software as a service without even realizing it quite often. We use like Office 365, which is now called Microsoft 365. We use Salesforce online. We use lots of different tools online where the company that owns that software, they're doing everything and we're just using it as consumers. So that is software as a service in one sense. So we as consumers do not have to write any of the software. We don't have to run the software. We don't have to configure any of the technology, any of the infrastructure, and so on. And so that's software as a service on the consumer side. So some people call that platform as a service, and that's not really what platform as a service means. Software as a service on the host side is if you imagine being Microsoft and providing that service, what you have to do behind the scenes to make that work. So if I was Microsoft and I'm providing Microsoft 365 or Office 365, the issues that I have to deal with are I'm dealing with multi-tenants. So I've got lots of different people, different companies using my software, and I have to make sure each one's data is secure from everybody else's and isolated and so on. So for example, North Highland has Office Word documents and so on up there. We don't want Accenture being able to see our Word documents, that kind of thing. So Microsoft, as the host of the SaaS, has to worry about multi-tenant issues, that kind of thing. They also have to worry about SLA issues. So Microsoft has to make sure their software is up and running, 99.99% of the time, something like that. And the governance and security issues, again, making sure that the data is isolated and so on. So that's the host side. So remember, our customers, our clients, they may need either one of these. They may need software as a service, Office 365 style or Salesforce Cloud style, or they may need to actually host it for their customers. And so, that's the two different types of software as a service. Any questions before I go on that? Is everybody still there?
I'm here.
That's great.
Oh, good. Okay.
I was going to say, no, still here and you're doing great.
Yeah.
Okay, good. Okay, just checking.
Yep.
Just checking you're all still alive. Okay. So there's some other cloud models that are less well known. DB as a service, which is database as a service. Table as a service and function as a service. So database as a service, typically Aurora DB in AWS would be that. And that is a case where you don't have to set up your database. You don't have to configure your database. You just use the database. It takes care of things like replication for you. It takes care of things like backup and restore for you. It's very resilient. It's very available. It's very scalable and so on. And table as a service is even more um, kind of convenient for the user, if you like. So all the user sees is the table. They don't even have to know about the database. All they know is there's a table up there and there's data in the table. They don't have to know anything else about the database. So that's another type of service. And then function as a service, this is kind of the platform as a service thing that we were talking about before, but in a different light. So this is the idea where somebody else creates a function for you and you use it as a service. So you will just run that service within your cloud, that kind of thing. So why cloud? Why do our clients need cloud? Well, to understand why people want the cloud, you have to go back to the old days of how we used to do it before cloud and so on, and how some of our clients still do it as well. You might decide you need to write a website, so you're going to need a web server, so you kind of order it online maybe, and it'll take 3 or 4 days to come in, and you have to decide what CPU size you want, what RAM you want, and how much hard disk space you want, all the configuration and that kind of thing. Then you get it on your desk, and then you have to set up the operating system, and then you have to configure various software on that operating system, and you have to make sure that all works. And then you have to worry about security and scalability. And then you realize, oh, actually, I need another server. I need an application server so that I can separate my web server from my application, because when it scales up, I don't want them both to have to scale up at the same time. Maybe I need a database server as well, and so on. And it gets big very quickly. And some of our customers and some of our clients have huge data centers by now, and they're managing servers in this way. And it's really, it gets very complex. You have to manage patches, operating system patches, and so on. This is the old days, and this is why it's very complicated to do it this way. So along comes the cloud to save the day. So pretty much in the cloud, everything is ClickOps. You want a server, and you click a button and you say, I want it to be a Linux server, or you say, I want it to be a Windows server. And then you might say, I want this amount of memory or that amount of memory. And you might say, I want this database with it and that database with it. You just basically click and choose, and voila, you have a web server. And automatically involved in that, some of the things are taken care of for you by the cloud provider. So it can scale up, it can scale down, you can have security built in and governance built in. A lot of the technical support part of this is taken care of for you. A lot of the resilience is built in. So for example, if I have a web server that went down, another one comes up in its place immediately, and the customer probably never even notices that web server went down. So that's the kind of thing that clouds are useful for our clients and our customers. So how does all this happen? One of the ways that this can happen is the ClickOps method that I talked about before. Another way that it can be done is what's called infrastructure as code. Now, typically, this is almost like writing a program to say, I want this kind of server, or this kind of firewall, or this kind of load balancer, and so on. And nowadays, this is part of what we call DevOps or DevSecOps. The DevSecOps is when the security is built in, kind of thing. So in AWS, for example, the options are listed here. So you have CloudFormation templates, which are basically YAML files or JSON files, which are basically just files with key value pairs in them, pretty much. That explain to AWS what kind of server you want, what kind of load balancer you want, what kind of firewall you want, that kind of thing, what users you need to set up, that kind of thing. Everything can be in there. Terraform and TerraGrunt. I'll talk about Terraform first. Terraform is a bit like the CloudFormation templates, except that it kind of works on different platforms too. So it doesn't have to be just AWS. So you can get Terraform templates, but just by using your search engine, you can find templates that will work in AWS or Azure or Google, for just about anything you want to do in the cloud. So if you want to set up an EC2 instance in AWS or a virtual machine in Azure, you'll find a Terraform template out there on the web that will do that. And you can add into these Terraform templates as you go along and as you grow and as you learn, and try to make it as dry as you can, so you make it so that you don't repeat yourself and you just reuse the same code or the same templates. That's kind of the idea behind Terraform. And TerraGrunt is like another layer on top of Terraform that only really works with AWS, but it builds in all of the security and compliance and multi-account architecture and all the things you're going to need for a big project. TerraGrunt makes it really easy, and it basically generates Terraform for you that's all reusable and reusable templates and so on. So that's what they are. Then there are scripts. Obviously, a lot of you have used scripts in your daily lives, I'm sure, and command line options. In AWS, there's what's called the CLI, the command line interface. And you can develop lots of scripts in there. You can do it in Python. You can do it in PowerShell. You can do it in just about anything you want. Many of these options here are predefined somewhere. So you'll find whatever you want to do somewhere out there. AWS, for example, has a lot of CloudFormation templates already done for you. So you don't have to even think about what all the options are. They've got it all built in there for you. And you can just reuse their code. So you can just write code to create just about anything, any piece of infrastructure that you need. And these get better as your project matures. So the more you learn, the more you build into your templates, the better your templates get, and the less work you have to do to support your infrastructure. And it becomes part of your code as well. And you check it all into something like GitHub. It's source code for your whole environment, not just for your code. This is a bit fuzzy, I'm sorry about that. I wanted to explain why cloud is so good because of this kind of the repeating circle. Basically, this is how cloud works for big customers, for example. So if you imagine someone like the company I used to work for, Micro Focus, they have lots and lots of customers using lots and lots of tools, and they're moving to the cloud. So for example, as they get more customers, they use AWS more, their infrastructure, they use more infrastructure, and the economies of scale go up, so their costs go down, so they make more profit. They can either reduce prices or just make more profit, and it goes around and around. They get more customers if they reduce the prices, and so on. And it's kind of a virtuous cycle, I guess they call that. So that's one of the advantages of cloud computing for our big customers. Some of the other advantages here are, trading the upfront capital expenses for the more variable expenses. So for example, you don't have to pay up front to buy 10 servers and all the stuff that goes with that, the databases, things like that. You can pay on a monthly basis or on an as you go, pay as you go method. The cloud provides a lot of great pricing models, so that's really attractive to a lot of our customers. It can increase speed and agility. So these CloudFormation templates and Terraform, the infrastructure as code, they can make it very fast to build a whole environment out with all the infrastructure you need and all the code that you need very quickly, and change that very quickly and get new code out there very quickly. For example, the Kubernetes and so on, you can just fling a new container up to Kubernetes and it'll be running almost within a minute. It's very quick. You get the benefits from the massive economies of scale we just talked about. You don't have to spend lots of money running data centers and so on, because basically AWS or Azure, they do it for you. They maintain the data centers, they maintain the physical security, they maintain a lot of the hardware security and a lot of the firewalls and so on. You can stop guessing capacity. There's great tools in the cloud, especially in AWS. There's CloudWatch, which tells you, any of your computers, you can find out at any time how much memory it's using, how much disk space it's got left, how much I/O is going on, that kind of thing. There's a lot of tools for finding that information out. And you can go global in minutes. So just about all of the cloud providers have options for, making your web servers available in any region in the world, pretty much. They all have multi-regions. In each region, they have what's called availability zones. Availability zones basically mean you've got kind of disaster recovery and failover built in, so that if one web server goes down, you can use another one very quickly and very easily, and so on. So this is the environment that we're working in technically on a technical side. We're moving from manual provisioning to infrastructure as code, which is the Terraform and the CloudFormation templates I talked about before. The manual server configuration is now just configuration management that's kind of just scripts and built in, or YAML files and so on. The application config is moving to configuration files all the time now. We're all using YAML files and so on for that. The builds are all continuous integration. So the idea is that, every time you have a new change, it theoretically could be integrated into the production system within minutes, theoretically, depending on the gates and depending on the tests that you have at each gate, stopping it getting into that environment if something goes wrong, obviously, because you don't want bad code getting into production. But basically, you'd have lots of environments, and your build can go through all of those environments if it passes all the tests that are necessary. And that's also part of continuous deployment and continuous delivery. And the automated testing can be built into those pipelines, so that, again, you go through smoke tests, or you go through complete system tests, depending on which environment you're talking about, or just unit testing if it's in dev, for example. And the unit tests, if they fail, you can't even check in, maybe, that kind of thing. So in the database side, nowadays there's schema migrations. So rather than writing a piece of SQL to move all the data from one place to another and check for different scenarios and so on, you just have schema migrations, which make it really easy to move up to a new version of the database, if you like, and also to roll back, because sometimes that's needed. And then there's also automated specs. So you don't have to spend your time writing specs and documentation, because some of it's automated and it's kind of in there already. If you use cloud correctly, you can make your applications really well structured, well architected, including things like isolation and decoupling. They have things built in, things like queues built into their systems. AWS has SQS, which is the queuing system, to decouple things like the front end from the middleware, and so on. Or if you've got something coming in from outside at a fast rate, and you can't handle it quite so fast as that, you can put it into a various number of devices to stop it overpowering your actual application. One of those is queuing. There's various other options. Then you have the modularity and the redundancy. A lot of the cloud options help perpetuate that, help to encourage you to make modular code, make code redundant, and make infrastructure redundant too. And following solid principles is easy in the cloud. They make it very easy, and there's a whole course on that. I'm not going to go into that right now, but a lot of the programmers on this will understand what I'm talking about there. So why not cloud? Why are some of our potential clients and potential customers, why are they not moving into the cloud, or why are they scared to move into the cloud? Why do they choose sometimes to go hybrid, or what we call cloud on premise, which is where they basically get part of the cloud and put it on premise on their own systems? So there can be security issues, compliance issues, data governance kind of issues, control issues. They want to have control over their data and their systems and so on. Billing issues. One of the scary things with AWS is the first few months that you use it, you don't really know what the bill is going to be, because it can be difficult. So now they're building in a lot of mechanisms to help you work out and predict what the bill is going to be, and how much of these different components you're going to use, and so on. So there's options available for hybrid for those clients that are scared of this stuff, like cloud on-premise, which we call Outposts on AWS, Connect Direct and VPN. So Connect Direct in AWS means connecting your data center to the cloud directly. VPN, a lot of you know VPN. There's basically different VPNs options available to connect your cloud networks to your on-premise networks. So there's all kinds of options there. So if anybody comes across a client that is in this scenario where they want to go hybrid because they're too scared to go full cloud, recognize that that is a valid concern to some extent. But nowadays there's a lot on most of the cloud platforms that makes it not an issue anymore. There's a lot of security built in, a lot of compliance built in. I used to be a security auditor, so I know the kind of controls they need, and AWS has taken care of a lot of those. So it's not as much of an issue as it used to be. Shared responsibility model. This is how AWS likes to present it, but it's very similar for Azure and for Google. Basically, the cloud provider takes care of some of the stuff for you, and you have to take care of other stuff. Now, when you're talking about infrastructure as a service, so things like your virtual machines or your EC2 instances, this is kind of how it works. AWS takes care of the global infrastructure, like the regions, the availability zones, some of the foundation services for compute. Compute basically means your computers, your servers, your virtual machines. Storage, which is basically just file storage and that kind of thing, object storage. Databases, there's a variety of database options, and networking, various options. The other stuff is kind of the customer's responsibility, but that's good because you need kind of that control in lots of scenarios. Now, when we're talking about platform as a service, or the functions, the Azure functions and the Lambda and so on, AWS takes care of more of this. It kind of goes up. So that arrow on the right is pointing up, because AWS is and other cloud providers are offering more and more that they do for you, and you don't have as much responsibility. So that's, this is heading in the upwards direction. So the business side, if you happen to be on a project where you're trying to do some sales to a client, you're trying to encourage them to go in the cloud, that kind of thing, one of the ways to encourage them to move into the cloud is to think about it as a change management exercise as well as a technical exercise. So they have to change their culture to some extent. They have to change their way of thinking about their organization if they're going to go into the cloud. And one kind of de facto way of doing that is to create what's called a cloud center of excellence. This is what we did at Micro Focus, and it worked really well. You get basically the key people in the company who really know this stuff. There's a whole list here, and get them all into the cloud center of excellence, and they kind of set the direction for the company. So this is obviously something you'd do with a big company, a big client. So first of all, you look at strategy, buy-in from the top. You need the top guy to say, or top girl to say, this is really important and we need to do this, to come up with a roadmap and a way that we're going to move the company from what it is now to what it will be. Look at the change management side, the psychological side, because people are scared of change. Look at communications throughout the company to make sure people know what you're doing. Determine which parts we're going to move to. So are we going to do everything lift and shift, infrastructure as a service at first, or are we going to do some Azure functions or some Lambda functions? Or are we going to do a SaaS environment? Are we going to use tools that other people create for us, like Office 365, Microsoft 365, or Salesforce Online or Cloud? Or are we going to offer software as a service ourselves? Are we going to be a provider for that? Look at security and governance right from the start. How are you going to control things? How are you going to build in security into the architecture, and you can do that through the code, the infrastructure as code, the Terraform and the CloudFormation templates pretty easily. And then this center of excellence will provide guidance on architectural decisions. There'll be a couple of architects involved there, constantly reviewing the roadmap and the way forward and helping with architectural decisions. There'll be some training and education needed, some QA and testing right from the start. Think about how you're going to test this thing, how you're going to build quality into the whole system. And that's a whole other presentation. And how you're going to manage different accounts. So typically in a cloud, you'll have accounts. And for example, one department might have one account, another department might have another account. You might have accounts for dev, for staging, for prod, so development, staging, and production. You might have accounts in different ways. So you've got to think about how you're going to do that and how you're going to manage that. And then plan for how you're going to implement with the business. So how does the business work while you're moving to the cloud? Which things will be done on premise? Which things will be done in the cloud, and how? Also plan for support and maintenance, although there won't be as much of that once you get into the cloud. You still have to work out how that's going to happen. And monitoring, so for example, APM, application performance monitoring tools, things like Datadog, New Relic, and so on, that you're going to use to work out what's going on in the cloud, which systems are having trouble, how we're going to deal with that. A lot of this will be automated in the cloud, or it can be, but you may have processes around that. You might want to notify different people that problems are happening, and so on. And then DevSecOps, of course, the whole CI/CD pipeline and beyond, the whole idea of getting your code into different environments, the gateways, and what they have to do to get into the different gateways. For example, they might have to do security tests. They might have to do things like we use Fortify on Demand and Web Inspect and Sonatype and SonarQube. All those kind of things might be built into the pipeline before you get into a different environment. So work out what criteria needs to happen before you get into the different environments, and build a gateway to say you can't get in there unless you pass that. And then there's Scrum and Agile, of course. We all believe in Scrum and Agile in this company, and that's a really good way to have fast provide deliverables in a fast method and keep the customer really involved in the whole process. And you've all done the Agile course, I'm sure, so I don't need to go over all that. One of the ways to make this work is to have a pilot project in a company that is considered sexy, like it does something really exciting. It involves all the best programmers in the company, the best technical architects in the company. Everybody wishes they were on that team. Everybody looks to that team for help when they need it, that kind of thing. So that helps make this change management process work. And also consider TerraGrunt, or at least Terraform if you're moving to infrastructure as code, just because it'll make your life a lot easier long term. So that's another thing from the business side. Does anyone have any questions? Everyone's very quiet. No? Okay. So technical tools to help. So it varies with company culture, size, and industry. But things like Control Tower is really good in a big company for governance. Control Tower is an AWS tool. They've got a similar tool in Azure I don't know the name of.